High availability or HA pairs form the foundation of two-node and multi-node clusters. In this scenario, an HA pair is cabled to create a two-node cluster. Follow the same process when cabling additional HA pairs to create a multi-node cluster. The scenario uses two storage controllers with 4 onboard SAS ports and quad-port SAS host bus adapters, or HBAs, in expansion slots 3 and 4. The storage controller attaches to 2 shelf stacks, each of which contains 3 drive shelves. The shelf IDs follow the recommended practice. Shelves in Stack 1 are numbered starting with shelf ID 10. Stack 2 shelf IDs start at shelf ID 20. As for a single-node cluster, identify and sequentially record all the available A ports, 0A, 3A, and 4A. The A port is on the right end of the HBAs in slots 3 and 4. PCIe card on the right side of storage controller are mounted upside down. An easy way to remember this placement is to note that the A port is farthest from the chassis backplane. Next, add all the available C ports to the list of ports, 0C, 3C, and 4C. Discard any port numbers that are in use or that are reserved for use by a non-shelf device, such as a SAS tape library. Write down all available B ports, 0B, 3B, and 4B. Then record the available D ports, 0D, 3D, and 4D. Finally, shift the first B port to the end of the line. You now have sets of ports that do not create a single point of failure, or SPOF. If you see that the ports for the first or second shelf stack create an SPOF, shift the bottom line to the left again until the SPOF is moved to the end of the port pairs. If SPOFs cannot be eliminated, ask the customer to purchase another HBA to put in an available expansion slot, then rerun the algorithm. This cabling diagram shows how the port selection algorithm translates into cabling an HA pair of storage controllers to the shelf stacks. Each storage controller uses the 0A port to create the primary paths to the first shelf in Stack 1. Each controller uses port 3B to create the return path from the last shelf in Stack 1. On Shelf Stack 2, each storage controller uses port 3A to create the primary path to the first shelf in the stack. Node 2 owns the drives in Stack 2, so connect Node 2 to the A/I/O shelf module and Node 1 to the B/I/O shelf module. Finally, create the return paths by connecting port 4B to the last shelf in Stack 2. Now that you have cabled the HA pairs and their drive shelves, you can cable the pairs together in a cluster. Cabling controllers that have an integrated drive shelf differs slightly from cabling external drive shelves. The first image shows a storage system that has 2 storage controllers and 24 drives in the same chassis. Each storage controller has 2 onboard mini SAS ports, 0A and 0B. These ports connect internally to the integrated drive shelf, but the ports can also connect to external drive shelves. You achieve a multipath high availability, or MPHA configuration, by connecting one path from each controller to each I/O module, or IOM, in a single stack of attached shelves. Connect port 0A from each storage controller to IOM-A and to IOM-B in the first shelf of the stack. Connect port 0B from each controller to the opposite IOM-B in the last shelf of the stack. You can envision the path from the 0A ports going from the top down and the path from the 0B ports going from the bottom up. The cables between the shelves are connected from the first IOM port 3 to the next shelf IOM port 1. These systems do not need any cabling to achieve an HA connection between the storage controllers because the path is over the backplane of the chassis. Cluster interconnect cabling uses 2 Ethernet ports, E0E and E0F. For a switchless cluster, connect these ports between the 2 controllers. For a switched cluster, connect these Ethernet ports to a cluster switch. The second image shows a storage system with an integrated disk shelf. This system has SAS2 ports for connecting to external drive shelves. To connect to drive shelves that use IOM12 modules, use cables that have mini SAS connectors on the drive shelf end and QSFP connectors on the controller end. For a switchless cluster interconnect, connect ports E0E and E0F between the two controllers. For a switched cluster interconnect, connect the ports on both storage controllers to a cluster switch. Network switches have slightly different installation procedures based on the make and model. However, the procedure can be reduced to a few general steps. First, attach any included mounting brackets to the switch chassis. Second, if the switch requires proprietary mounting rails, install the rails into the cabinet. A recommended practice is to space the rails so that there is a 1U air gap between switches. The gap makes plugging and unplugging cables easier and facilitates cable management. Next, mount the switches into the cabinet. Then connect the switches to redundant power sources. Before the switches can be used with NetApp storage systems, you need to configure the ports. Switch port configuration varies for each model, so see the documentation and config files on the NetApp support site. You can download reference configuration files or RCFs and firmware on the Downloads page. Use the most recent image version that is compatible with your NetApp ONTAP software. Cluster switches are not installed in two cluster options. In a single-node cluster, configure the node as a cluster. You should not need to configure any switch ports. A two-node switchless cluster requires you to directly connect the cluster ports between the two nodes. You should not need to configure any switch ports. The first task in cabling a new cluster is to cable the management and cluster interconnect switches. This example uses generic switches, which might not represent the port configurations of the switches that the customer uses. Although the process is similar for most switches, always review the documentation. For illustration purposes, this scenario contains a gap between the switch pairs. However, the only gap you need in the cabinet is a 1U air gap between the management switch pair and the cluster interconnect switch pair. Begin by cabling the interswitch links, or ISLs, to create a failover relationship between the switches. This relationship works like the high availability or HA functionality of storage systems. ISL cables are usually short, so use the correct cables from inventory. Cable together the ISL ports of the management switches. Then, cable the ISL ports of the cluster interconnect switches. Some switches use as many as 8 ISL connections. Dedicated interconnect switches access the customer network by connecting the management ports to port 13 on the management switches. This connection is only for the management and monitoring of the interconnect switches. Last, connect both management switches to the customer network to enable monitoring of the switches and email alerts from the switches. The customer should provide a network drop for this connection, so use the provided cables. Best practice is to connect the switches to a redundant pair of customer switches. Connecting both switches to one network switch creates an SPOF that might leave the customer unable to monitor or manage the cluster. Customers might want to substitute the fixed-length Ethernet cables that ship with the systems. If the cables are Category 5E or Cat5e or Category 6 or Cat6, this substitution is acceptable. Customers should not try to substitute twin-axial cables. The following cabling diagrams represent how to cable HA pairs to cluster switches. This demonstration of the process uses a dual controller FAS8060 system. Always follow the cluster cabling documentation for the FAS model that you're installing. See Hardware Universe to verify which ports to use. After you finish the switch cabling, cable the cluster nodes to the switches. First, use Ethernet cable to connect the management port of Node 1 to port 1 on the management switch A. Connect Node 2 to port 2 on the B switch. If you had more nodes, you would connect the odd-numbered nodes to the associated ports on switch A. You would connect even-numbered nodes to the associated ports on switch B. Best practice is to create a redundant management connection. To do so, use an available 1 gigabit Ethernet port. On the FAS8060 system, this port is the E0I port, which connects to port 1 of management switch B. During the cluster setup process in Module 5, you need to manually enter the name of the port that you selected when you defined the management LIF. Not all FAS systems have 1 gigabit ports, so you do not complete that step for every installation. Now create a redundant connection on Node 2 by connecting to port 2 of management switch A. If either switch goes offline, you still have a network route to monitor and manage each node. Customers can substitute their own Cat5e or Cat6 cables for the provided Ethernet cables. Next, cable the cluster interconnect connections. Ports E0A through E0D are 10 gigabit ports on the FAS8060 system. Connect port E0A on Node 1 to port 1 of cluster interconnect switch A. Connect Node 2 to port 2 of cluster switch B. As you did with the management switches, create redundant connections to the cluster switches. Skip port E0B and use port E0C to prevent an SPOF, which occurs if both connections are on the same ASIC. Connect Node 1 to port 1 of cluster switch B. Connect Node 2 to port 2 of cluster switch A. Not all FAS systems have on-board 10 gigabit ports. Many require two 10 gigabit Ethernet PCIe cards. The primary connection comes from the A port of the first card, and the redundant connection comes from the A port of the second card. Follow the cabling documentation for the FAS or AFF systems that you are installing. To manage the workload that larger storage systems process, many systems use 4 cluster interconnect connections. To reduce confusion when cabling the third and fourth connections, this diagram temporarily conceals the primary and secondary connections. Because E0A on Node 1 connects to the A switch, connect E0B to port 3 on cluster switch B. Do the opposite on Node 2. Connect E0B to switch A. Connect E0D on Node 1 to port 3 on switch A. Connect E0D on Node 2 to port 4 on switch B. Now, bring back the primary and secondary connections to see the final result. Not all installations create a cluster. Sometimes you add new systems to an existing cluster. To add this HA pair as nodes 3 and 4 of a mixed cluster with HA pairs using 2 ports, start with port 5 on both switches. Leave ports 3 and 4 available for a future tech refresh of the older systems, which need these ports for the third and fourth connections. A fully cabled 2-node switched cluster looks like this illustration. You cabled redundant 1 gigabit ports to the management switches. You then cabled the cluster interconnect connections. Now you can cable the customer-supplied network drops to the data network in preparation for the cluster setup process.